So I'm going to walk you through a side project I've been working on. So it's based on some stuff I've been diving into with SQLX and multi-tenancy, and it's also bringing together knowledge on semantic types, money precision, etc. in Rust. And this is an Axum-based project. So let's dive into it. I'm going to start the back end, and then let's try signing in. So right now the OTP code doesn't get sent anywhere, it's just dumped into the log. That's an extension at whatever point, so let's just change this. And the React side is really a work in progress, but it has a JWT bootstrap, protected routes, etc. And now if we go here, interesting. It's working. Okay. It was based on all the tokens. So we have the banks, we have the investments, and what I want to show you is how. Let's just look at how the feedback comes through. The response on the back end. Let's choose Hexarch. And actually, we don't want the Axios stuff. But that's fine. Let's look at investments. Oops, that's not the one. What am I looking at here? Whoops, hang on. Why is there no... response. Clicked on the wrong one. Here we go. So let's look at investments. So we get the investment data back. I want to actually make this a bit small, font size. Yeah, okay. Let's look at it like that. And so we have single investment coming back. This is in cents, but it's an I60, so it's a number in JS parlance, but JavaScript has an I64 limit because of the 53 bits is the max in JavaScript. Whereas on the Rust side, we are sending an I64 across. So in that case, this would be changed to a textual string. But for right now, I'm just sticking with this because you would be in the trillions of cents to get there, I believe. In any case, what I want to show is this computed property, which is total. So for example, let's walk through the process of adding a new investment. And again, this is just very initial stuff. The front end is purely just there to drive a quality Rust code base with Hexarch and etc. So the focus is on the Rust side. This is something I put together very quickly, just as a proof of concept. And of course, there are tests on this side too. Like, for example, if we go to create bank, I'm test driving it. There is integration tests, etc. Right? Fabric unit tests. So, like for example, you can come back here. Let's just do just test. This should run through. So so there's quite a bit of scripting going on. So DB truncation and so on and so forth. But here we're running just the test suite, and then it runs all the unit tests and integration tests. And also let's do a full build as well. So I can actually kill this and just do just dev. So this does multiple things. It not only builds, it runs Clippy, it runs all the stuff that you expect essentially, and it should be warning free. Yeah, it is pretty decent so far. Okay, so let's go back. We're starting the server again. And now we're going to just refresh one more time. And then I'm going to pick a bank. We're going to add test 001. We can tweak currencies later. This is meant to be a drop down. I haven't broken it out into one so far. Let's just make this 653, I don't know, 23 cents. Let's just add a 2.22 invest, yeah, what a rate. I can also show you I got some DB constraints to prevent switching these the wrong way around. So right now there's no JS level check on that. Let's go here. So we get a decent error response to the client with the status code, so that makes the life of handling errors on the front end quite good. And also here we have the log level, right? So this is basically coming through. The error is picked up in the service, and then this is the handler itself, the HTTP handler. Now if we go back and we get this the right way around, we can create it, and then once we create it and we go back, we find our investment has come into the system, right? And then we can see the totals have been computed to reflect the total of the two, right? And what I'm going to do is I'm just going to come back here and I'm going to cheat a bit. First, let's go to the account. Let's get my account ID. And I want to bring in some other currency stuff. So let's just do this as LKR and account number, and update it. And keen-eyed amongst us joining us at least will notice this. So the account number field is encrypted at rest. We can go into tree view, and then we can see it's a long string. This is PGP, encrypted at rest within Postgres. That principal amount is in cents. There's no 653, right? Have I refreshed it? Here we go. It's in cents, and the interest rate is what's called basis points. So 100 basis points is like 1%, 200 basis points to 2% is 2.22%. And then we have semantic typing within Rust to help handle all the conversions. So we have that part going. We have a join table as well, so you can see how it handles the joining. And let's refresh this. Let's also bring in a bigger, let's go back to the normal table view, and what was the account number? Well, I think I still have it, right? So I can just change. Let's grab a big figure like this one, and I want to update that. So now I want to show you how I just did a bit of cleaning up, well, improvement, quality of life stuff. So we have this small figure, and you can see how it's kind of like, I should put like an approximate sign here, really. And if you go back down here, same thing. The totals are computed and passed across. So I'm quite happy this part is working nicely. And let's see. And also, I've also done a bit of decoration. So in the Rust side, it's not needed to send the name through, but it was easier to get the name here into the component by including it here as part of each investment, to prevent having to make a call to another endpoint just to fetch the bank by the ID and just get the name. And also, of course, on the bank's view, we have the bank side. So I also showed how the JWT aspect works. We have theming through Hero UI. So this is a Tailwind Hero UI white project, quickly slapped together. The whole point was to get it to work quickly, and then I can hand this over to someone who's way better at moving quickly in React to scale it out if needed, right? Take some of the workload off my hands while I focus purely on the Rust side of things. So let's close all the tabs. And I want to focus on the schema side first, because that's something I worked on here. So if you go back to my article, I'm talking about multi-tenancy and how we can use SQLX, and it's TOML file support for keeping things in different schemas. So the way I've done my one is we have an account, right? So the account ID is there. I decided to give a ref number, so that is for keeping a track on them in the future if needed. Because sometimes UUIDs get a bit wieldy, if you want to show it in a report or something. For that, I plan to throw in QR codes as well, so that's another task down the road, but essentially we have that. And the JWT stuff works on this, but this is something I did quickly and I didn't want to waste too much time, but I have the session table in place. So in a later refactor, what's going to happen is the verification code and probably, it'll switch into the session rather than being in its own table. And that way, every session will be tracked instead, rather than having to have a split table. And then if you come back here to the bank setup, so this is what I was thinking about. So conceptually, I was trying to go across entities, and then I basically came to the idea of having a split design. So we have account, and I think there's a trick you can do here to look at diagrams. Yeah, this is good. This is really good. So if we take the SQL migration, so you can see there's multiple of these, I think. So I think it's for like each of the schemas and stuff. So normally you won't have two, but you have three now because there are three migrations for the three schemas, I believe. So the way it works is we have a bank, we have the account. When I start off, I called the user, but later I changed it to account. And then verification. This is just for JWT. These are going to eventually become one thing, right? But this is what I want to do. This is still a placeholder. The idea there is we can track history of investments when they're renewed. So we can, keep a track of what's happening. Is renewed, uplifted date, so the date it's uplifted and disabled. But yes, that's the basic setup. So we have the account, the bank, and we have this join table between account and bank. So when a user creates a bank, we also create the association, join table mapping, right, to the bank. And then when we create an investment, it's already essential. It has a foreign key association on the account ID and on the bank. Okay, so that shows that part. And then I want to show how I did some of the way these things work. So for example, if you go to looking at creating investment, right? So this is where we have the encryption key coming in through from the environment. And since we are doing the encryption on the column, it has to be passed like this. So we encrypt it on creation, but since we're returning as well, right, this is a query as, we're returning it back on the create. We have decrypt as well. So if we didn't return it on create, then we won't need to have this. And also in SQLX, there are some interesting things, gotchas, for example. The decryption could fail, so we have to tell SQLX that it's not going to fail, etc. But basically, this crate will is this crate itself is its own island, right? So this handles everything to do with investments in the Postgres domain, right? That's the important part. So if you look at this crate, we have a dependency on SQLX, and on the accounts crates, that's this one. And then if you come here, we have the account stuff. That's just for the GW out. But then we have other things going on here for updating passwords and all that stuff, right? But now let's go through back to where this gets more interesting. So if you come to the service side, this is where we have our domain level logic. This is where everything starts for me, essentially, in a service. So if you go to the ports, this is again Hexarch, right? We have our service port. I decided to call it service port so I can remember this is what it is, because when you have service all over in your code base, it gets confusing. So I like to have that, slight definition, because also easier to search for this, right? If I do search, I can search by that directly, whereas if it's just banking service, it'll come up in a lot of other areas as well. So overlap is an issue, so I like it doing it this way. And then from the service port, we also have the repository trait. And so now I'm going to walk you through how the handler works. So we have, this is more Hexarch than the typical domain-driven design, but still there's overlap. So let's come here. Let's look at the creating an investment. So we come through. Where is our handler? Here, this is the handler is right here. So the handler looks like this. We come through, we have JWT auth in an extractor. We convert the HTTP request into a domain domain semantic types, and then the service hands off to creating an investment. And that comes here, and this is now where at the service level, right? Now we can do other validation, essentially validations. You can do parsing if you want. You can do sanitization, etc. over here before you hand it off to the DB side, the repository side of things. And so if I click on this, it's going to take me back to my trait. So in Rust Rover, I like to do this, and you can click through into where you want to go to. And so this is the banking repository. So if you look at that, this is where I have like an outbound. So we have inbound, outbound. So it's very clear in terms of the directionality in our hexagon, right? If you want to keep that way, right? So outbound is obviously database. In this case, it could be a different outbound adapter or whatever you want to call it. We could be going out through gRPC or something else. But we know it's Postgres in this case, and then we come here. And so this, so what happens here is now, in a previous project, everything was coupled inside the repository. And I absolutely hated that because it felt like we were having these spaghetti of SQL calls. So right, for example, now, so I mean, sure, it makes sense, and it is pretty standard for SQLX calls to be defined within the repository itself, as it normally goes. But what I found was it's much harder to isolate testing when it's like that. So the way it works now is I can come in through here and I'm piecemealing to create an investment, right? I use the accounts manager, which is part of the crate I showed you earlier. So if I go down, it's inside my persistence namespace for crates. So accounts manager, let's look at that. It goes here into that project right there, the lib. So it's this one, the Postgres accounts. So this is now my SQLX multi-tenancy type crate essentially. So accounts manager is like this. It's where's it? SQLX type, right? Where is it? Sorry, go scroll up much more. Here we go. SQLX type on the account ID, and that handles all the conversions and stuff. Where was that? Sorry, lost my train of thought. Let's go. Just ignore the errors and stuff. But yeah, so we come here, we do the setup. So when you call setup, which I only call in the server crate, right? I'm only calling new because I only want migrations to run once when the binary starts, right? Not every single time we're calling through. So that's why we do new, and then from here we can come and do create account, whatever, find by email, all the usual stuff. So let's go back. I'm just going to step backwards to get back to where we were. Yeah. So here I'm just basically saying get this from my semantic type, right? And I'm converting it back into whatever type I need to do that. So anything in the domain service side is using these semantic types, meaning this one. And then we check that the bank exists, and then blah blah, and then here we're creating investment, right? Blah 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 blah. Hang on, what's this? Oh yeah, here we're just okay. Here we're getting the linked bank, and then we're doing some verification on that, and then we create the investment. And then here we do some interesting stuff with basis points, scaling, and here so we're basically going from a domain level semantic type to an I16 because we need to hand over an I16 to the database, and that's where this part comes in. So now here we're calling create on the DB side, and it's a different crate itself. That's the thing. So the main takeaway from this is I kept the repository trait in my main monolith, if you want to call it, but the actual call is a cross crate call, and so we have another interface helping with the isolation, and then errors get passed across as needed. And then we saw that earlier we had that failing check for flipping the start date from the maturity date, right? And so that DB constraint bubbles up, and we catch it here, and then we send it back up. We send it back up to the service itself. So now I want to go through what I was doing today, this part. So we fetch. So earlier when I was doing this, the type I had was just this type, just the vector. But instead what I did was I came up with the idea of breaking up into data and totals. The domain level has our currency and sense. So now sense is our semantic type. Okay. Now for notes on the semantic type, I have another blog post for that. It's this one. So dive into this and you'll see what's being done there. So now we have sense here, and then we come, so what I want to do is I need to compute this, right? So if you go here, what I did was I previously had this, just that, and I was returning just the investment records back. But then I wanted to do this. I want to have a total of um, the principal amounts and group it basically by the currency. So what we're doing here is we're doing an operation on sense itself on our semantic type, and we're basically creating a default 0 essentially, right? And then we just keep adding to our accumulator, and then the accumulated value is returned here. So of course this is not doing any caching or anything of that kind of stuff. It's just straight compute and return. And then that bubbles back up from this call, go back here, and then here we convert it. So now our fetch totals, see, it's in, if you look at the bottom here, it's hash map currency cents. So we now need to convert from those from that to this. So of course I could do a from conversion, I believe, but for the moment I left it like this because it's easy to read it straight away, at least. And then here we do some other, what is this, a DTO? This is the investment DTO. So the reason this was done, to go from bank name to DTO right here. And then because I think it is investment DTO is the one that's being returned. Yeah. So if I click on DTO, here we go. Yeah, the primitive type in the HTTP response. So what's happening is we get this one back, which is from the domain itself. And I want to convert out from that, to all the intos and stuff, map into the primitive types, because the primitive types are ultimately what we're going to serialize into, right? So when we come here, our HTTP response back to the client is based on these primitive types. And so, like, for example, we can just do into and just convert as needed. Few things get, so non-copy types like this gets cloned because that's a string, right? Yeah. And then this is our response data, essentially, is these two types, which is represented here in terms of investments and totals. And then let me see, do we need to, so I also have some stuff for like configuration, setup, etc. And there's a whole lot more under the hood, stuff like testing. There is a CLI crate as well, which I am using. And then I also have a just file to handle like most, so like my dev setup is basically running all these commands here. So it says testing, formatting Clippy, SQLX, etc. And so this is now the main thing. And let me just also go back up to here. Is this my main crate? My crate lib. I want to double check if I can also do, if we do deny unused imports, and then can we also do dead code? Would that break anything? No, no, so that is very good. That's very good. So this is something that will help keep the code quality high, because we're outright denying these things. But so during development, when I'm moving quickly, there'll be warnings and stuff. So I keep it off for most of the time. But now I've walked through the basics of following the whole hexagonal chain from the. Did we look at the wait, the route handler? Are you sure the route handler? Yep. What's going on? Hang on. I think something is bugged on my thingy bob. Why can't I get the router? Has it frozen? That's weird. Wait, let me see if I can close all the tabs. Oh, I think my Rustro has taken a nap. Yep, Rustro has died. Yep. Okay, so that'll be in probably a future thing, but for now, my machine is really on its last legs, but we can see that this thing is still operational. And keep an eye on the blog. I'll probably write something up soon as I make more progress on this project. If you made it this far, thanks for watching. Leave a comment down below and let me know what you think. Cheers, bye.